This video will cover section 4.4 trigonometric functions of any angle. So far, we have looked at the special angles such as 0 radians, pi over 6, pi over 4, pi over 3, pi over 2, pi, and let's see, what else? 3 pi over 2, and 2 pi. And so what we're going to do now is we're going to extend those concepts to evaluate trigonometric functions of any angle. But we're going to use the previous knowledge that we have gained from sections 4.2 and 4.3. For that, we're going to be using reference angles. And based on those reference angles, we'll be able to relate them to the special angles that I was mentioning. And with that, we will evaluate trigonometric functions of real numbers. So we have here something that we've already been going over. And when we were talking about the unit circle in section 4.2, we were using radius. The radius of the circle was equal to 1. So we were referring to the sine of an angle just with the coordinate y, because the unit circle, the radius is a 1. I did already explain a little bit about how if we keep making concentric circles that are concentric means they have the same center, which is at the origin. So even though it's not the unit circle, you will always have the same triangles, as you can see here. And so similar triangles, they do have the same ratios. And so that is why that we can extend this to a circle with the radius of any number. So we have the sine of theta equals to the ratio of y over r. Cosine of theta is x over r. Tangent of theta is y over x. Cotangent of theta is x over y. And remember that on last section, we went over these things called quotient identities. And we established that tangent of theta is equal to the sine of theta divided by the cosine of theta. So if I was to write it this way, it will still be true. And if we use the values that we have for sine of theta, that will be y over r, and divided by the cosine of theta right here, which is x over r. And so if we divide a fraction over a fraction, we can multiply the outer quantity. So that will be yr. And then the inner quantities r times x. And we could see here that r divided by r is going to cancel because it is equal to 1. So at the end, we are just left with y over x, which is what we have here for tangent. Cotangent, reciprocal of tangent, so you already know it will be x over y. And then finally, we have the last two. So sine is the reciprocal of cosecant, so it makes sense that we have r over y, the reciprocal of this one, and we have that secant is the reciprocal of cosine. So it makes sense that instead of x over r for cosine, we have the reciprocal of that, which is r over x. And of course, we're using x and y as the unknown x and y values, and r is the radius of the circle. And in case you didn't know your radius, what you will need to do is use the Pythagorean identity. And so it will be like if you had a triangle and you were trying to find the hypotenuse. Instead of calling it c square, so the Pythagorean theorem goes like this: c square is equal to a square plus b square. And so if we take the square root on both sides, it looks like c is equal to the square root of a squared plus b squared. So what we're saying here is that instead of c, we're using the letter r for radius, and instead of a and b, we're using x and y. One last thing I want to point out from this triangle, and before I do that, I'm going to erase some stuff that I have here. It's a little too crowded. Okay, so here the angle that we are talking about, theta, it is in standard position. Remember, standard position is positive x-axis. That is the initial side of the angle. And then the terminal side, it happens to be here. And so the angle goes from positive x to the terminal side. That is the angle theta. However, the term that I mentioned earlier, reference angle, is going to be the angle that if you were to draw a perpendicular line from the end of the terminal side to the x-axis, the reference angle is going to be the angle that is made from that x-axis to the terminal side. And so that angle, we will refer to it as theta prime. So we have like a little apostrophe there. And that is the reference angle of this one here. A reference angle is always acute, and it is always positive as well. Since the sine function is defined as y over r, and cosine is defined as x over r. Now it follows that because r is a radius, it cannot be 0. And if you have a circle with a radius of 0, you're just talking about a point. So because that cannot equal to 0 or any negative number, the sine and the cosine functions are defined for every single angle. However, if the x is equal to 0, then we have problems with tangent, because tangent is defined as y over x. Also, secant, that will give us trouble as well, because secant is defined as r over x. And so if x was to be a 0, then we will be dividing by 0, which it is undefined. So when x is 0, then tangent and secant are undefined. Let's see what else. So if the y is equal to 0, then the two functions that will be undefined will be the cotangent. Cotangent, I want to remind you that it is x over y. And for cosecant, which is the reciprocal of sine, and that will be r over y. So it's pretty easy to see that if we divide by a 0, if y was to be 0, then it will be undefined. Now, where do those things happen? So I'm going to draw just a rough sketch of the unit circle. And remember, because it is the unit circle, we know the coordinates of the points that are touching the x and the y-axis. So I'm going to start from the positive x-axis, and the coordinates there are 1, 0. I'm going to move counterclockwise in this direction, and so this coordinate here will have the coordinates 0, 1. And the very next one at pi radians is going to be -1 for x and 0 for the y. And then the one that is next, it will be 0, -1. So we could see that when the y is equal to 0, that will occur here and here. And when the x is equal to 0, will happen here and here. And just to make sure we're all on the same page, let's go ahead and label our circle with respect to the angle measure. So that could be either 0 radians or 2 pi. 2 pi. And here we have pi over 2 or 90 degrees. Here we have pi or 180, and here we have 3 pi over 2. And so for those four, the quadrantal angles, we have to be careful. So for instance, at 90 degrees, the x value is 0, and also at 270 degrees. And just so you know, in radians, 90 degrees is pi over 2, 270 is 3 pi over 2. So for those two angles, the tangent and the secant will be undefined. Now, speaking about the other two, at 180 degrees, which is equivalent to pi radians, and also at 0 degrees, which is equivalent to 0 radians, or at 360 degrees, which is equivalent to 2 pi radians. So at all of those, both of them, the y value is, because the y value is equal to 0, so therefore the cotangent and the cosecant will be undefined. So we have to be very careful with that, and perhaps for your exam you might want to write that on your formula sheet. With our first example, we're going to use a point, the point -3, 4, which is already plotted here. And now we have the graph, but if you don't have the graph, even if you're just working on your homework, you always want to have some scratch paper with you. And the first thing that you should do is to plot that point, because that will tell you a lot of what you need to do next. So -3 for the x, that's -1, -2, -3, and then 4 for the y value. So 1, 2, 3, 4. And I'm just showing you this because you will not always have the point, of course. Then what you need to do is connect that point to the origin. That's how you draw your triangles. From there, we're going to go to the point and just draw a perpendicular line from the point to the x-axis. So now that is the triangle that we're going to be using. So the angle that we have here for theta is in standard position, so it makes sense that it starts at positive x until the terminal side. So that is theta, is here. However, what we will be using, and the definition will come here in a minute, will be the reference angle, which is the angle that gets formed with the terminal side of the original theta and the x-axis. So it will be right here. So this will be theta prime, and that will be the reference angle. So let's see. If we were talking about just a triangle, the triangle will have the sides. For the x value, you can see that there are 3 units. So the absolute value of -3 is equal to 3, right? So we will be using 3. And for the y value is +4. So we'll put our 4 here. So what do we do when we know 2 sides of a triangle but not the third one, and it happens to be the hypotenuse? So we will use the formula c equals to the square root of a square plus b square. Similarly, you could think of it in terms of we're looking for r. What's r? So r will be the square root of x squared plus y squared. So either way you look at it, same thing. So let's use the x squared and y squared. So from here, what I'm going to do is substitute, and you should recognize what we're going to get a 5. And that's because these are the famous Pythagorean triples. So if I substitute a 3 here, And even if that 3 was to be negative, once we square it, it's going to become positive. So yes, this 3, if we're looking at the unit circle or the Cartesian plane, this 3 is still negative 3. But if we're looking at a geometrical triangle with positive dimensions, because that's what dimensions are, then it will be positive 3. However, here we're going to respect the negative 3, and you will see why as we move on. So this will be 4 and this will be 5. But let's go ahead and confirm this. So we have negative 3 squared plus, and I'm going to zoom in a little bit. Okay, this looks a little bad. Okay, that's better. So we're going to have negative 3 squared plus the y value, which is a 4 squared. And from here, recall that first we need to do the squares before we can add the two numbers. Negative 3 squared, you need to remember this. Anytime you square a negative number, negative 3 squared, the sign also gets squared. And so negative times negative is positive. So that's why the answer is positive 9. So 9 plus 4 squared is 16. This is going to give us the square root of 25, which is going to be 5. Now, if you're wondering, should it be 5 or negative 5? Both numbers are valid. However, for the radius, because it is actually a length, we're going to always use the positive one. So it will just be the positive square root of 25, which is positive 5. So now we know for sure that the radius is equal to 5. So now let's see what they want us to do. They want us to find the sine, the cosine, and the tangent of theta. And of course, we could always find all of them, but let's just do what we're asked. So we're going to have sine of theta, and that by definition is y over r. And so that will be 4, positive 4 right here. That's the y value. And the radius is 5. Now let's see for cosine of theta. The definition is x over r. So the x value is negative 3. And yes, we do need to use negative 3. And r is positive 5. For tangent, okay, having a little issue. So for tangent is going to be y over x. And so the y is positive 4 and the x is negative 3. Now here you can make the choice of putting the negative with the 4 when you enter your answer on web assign, or you could also have the negative and then call that tool fraction, that fraction tool, and then and the negative is kind of like right next to the fraction bar, and then you will put your 4 and your 3. So any of those answers will be okay. So let's move on to the next example, and here we just needed the first 3, sine, cosine, and tangent. Okay, now why is it very important to keep the negative sign? So I want you to remember that sine is defined as the y value divided by r. And we know that r is always positive. So it makes sense that when the y is positive, the sign of the sine is going to be positive as well, because the y is positive here. Remember? Positive x, positive y, negative x, positive y. So in quadrants 1 and 2, the sign will be positive. But if we move on to quadrants 3 and 4, you could see how sine is negative because the y value is negative. and that is the reason. Okay, so now let's look at cosine. Now, cosine is defined as x over r. And so whenever the x is positive, such as in quadrant 1 and 4, the sign of cosine will be positive as well. But whenever in quadrants 2 and 3, you could see how the x is negative, and so that is why cosine will be negative, like that. So remember, cosine depends on the x value. So in quadrants 2 and 3, cosine will be negative. Now the next one is very interesting because it is tangent. And so we already know that based on the quotient identity, tangent is sine over cosine. And so if we had, based on the definition, tangent is also y over x. So imagine here, if you divide a positive over a positive, you will get positive. So the tangent will be positive in quadrant 1. Now let's move on to quadrant 3. So if you divide a negative by a negative, you also get positive. And so that's why tangent is positive in quadrants 1 and 3. Only in those two. And of course, it makes sense that tangent is not positive in quadrants 2 and 4, because if you look at your x and y coordinates, they have opposite signs. So whenever you divide something of opposite signs, well, two numbers with opposite signs, you will get a negative answer. And so that's why tangent will be negative right there. Okay, so let's move on to the next slide. And now we're getting to the definition of the reference angle. So the values of the trigonometric functions of angles greater than 90 degrees or less than 0 degrees can be determined from their values at corresponding acute angles called reference angles. So first of all, a reference angle will always be acute, meaning less than 90 degrees, but bigger than 0 degrees, of course. And if we say that they're bigger than 0, then we're also saying that they are positive. Okay, no, actually, I'm not going to use that word. Okay, definition of reference angle again. So let theta be an angle in standard position. Remember that standard position is always when you start on the positive x-axis. That is what standard position means. And it's also, its vertex is at the origin. So this angle is in standard position. That's theta. This angle also is in standard position because it starts on the positive x and then it goes this way. So that is theta. And here's the terminal side. Okay. And the third example that we have, even though it's going in the negative direction, oh no, it's actually just a really big angle. So it's still positive. So we start here at the positive x, and then we go 3/4 of a turn and then a little more. So that is what theta is, that big angle, bigger than 270 degrees for sure. Okay, so now if we consider the terminal side of each angle, which is here, that's the terminal side, and we draw a perpendicular line that touches the x-axis, we're going to form a triangle. And so the angle that is between the x-axis and the terminal side, the one that is closer, that is what we call our reference angle, and that is theta prime. Okay, let's look at the second example. So I'm going to use the terminal side, and I'm going to draw a perpendicular line with the x-axis. And so the angle that is between that x-axis and my terminal side now, that is the reference angle theta prime. That is theta prime. Third example, we do have that big angle. So I'm going to do the same. I'm going to take the the terminal side and draw a perpendicular line with the x-axis. So now the angle that is in between the x-axis and the terminal side, that is theta prime. And actually, I'm going to zoom in here. Oops. Okay, and that will be theta prime. Okay, so all of those are reference angles. And so let's go over the definition again. So the reference angle is going to be acute. If you look at all of our theta primes, they're acute. They're less than 90 degrees. And they are formed by the terminal side. Here's the terminal side. Here's the terminal side of theta, and the horizontal axis, or the x-axis, however you want to call it. So there we have it, right there. And theta prime, which is the reference one, is the one in between those two, x-axis and terminal side. Okay, so now if your terminal side happens to be in quadrant 2, the formula to find your reference angle will be pi minus this theta right here. And so that will give you the reference angle, the one that goes from here to here. If your angle happens to have its terminal side on quadrant 3, theta, then to find theta prime, what you will do is take your angle, theta, and subtract pi, so that you know how many degrees or radians your angle theta went past pi. That's why we do theta minus pi. And of course, if I say pi, recall that's the same as 180 degrees. So this slide is very, very helpful for when you're doing your homework. And I mean, I will probably also add it to my formula sheet. Okay, and lastly, if your terminal side is in quadrant 4, then to find the reference angle, or theta prime, what you will do is take 2 pi, because that is the whole circle. And so you want to know, you take 2 pi and then you will subtract whatever theta is, because you want to know how far are you from completing the 2 pi. So that's why it is 2 pi minus theta, or 360 degrees minus theta. In example 4, we're going to find the reference angle theta prime when theta is equal to 300. So we could see that for theta, standard position, start at positive x-axis, go in the counterclockwise direction, and that will be theta. What is this? What that will be cover, and it is greater than 270, which will be placed right here. So theta prime is going to be the angle that it gets formed with that terminal side of theta and the positive x-axis. So theta prime is right here. Remember, it must be positive, and it must be also acute. So if you don't have those two, then you don't have the right reference angle. So let's see, how could we find this? So you could see that an angle of 300 degrees is actually getting very close to a full rotation, which is equal to 360. So we're just a little bit short of 360, right? And it's kind of easy to do this in your head, but just so you make sure, so you can write it down, it will be 360 minus 300. And that will be 60 degrees. So that will be theta prime, in other words, the reference angle. Let's move on to the next example, part B of example 4. Same thing, we're finding a reference angle. The first angle, the original angle, which we refer to as theta, is the one that starts here, positive x-axis, goes in this direction, counterclockwise, and here is our terminal side. That is theta. To find theta prime, that is made with the terminal side, and we draw a perpendicular line. I mean, it's not really necessary, but I like to do it to the x-axis. And so theta prime is going to be this little angle that goes from the x-axis, or the horizontal axis, to the terminal side. And remember, it must be positive and it must be acute. So remember that since we do not have the symbol for degrees, 2.3 is already assumed to be radians. And so because of that, we're not using 180 degrees or 360 degrees. What we're going to use is pi. And you could see it's already written there, but let's write it again. So it will be pi minus 2.3. And of course, for this one, you will use your calculator. And I wish I had my calculator ready already. So it will be, I will use the pi button. Remember, I showed you in one of the videos. And I'm going to subtract 2.3 from pi. And that will be approximately 0.8415 I guess. And the answer will depend on how WebAssign wants you to round it. So if they say round it to, I don't know, 3 digits after the decimal point, then it will be 0.84. You only look at the fourth digit, which is a 5, and that will turn this one into a 2. Any number that is 5 or bigger will make the number, the digit before, go up. So that's how you will round it. Now let's go to our last part of this example. And now we're going to have a negative angle. And so this angle, the original one, it's negative 135 degrees. So an angle like that, it starts standard position, and we go in the negative direction, which is clockwise. Clockwise is the when we get negative angles. So 135 negative, so we start here, and then here will be negative 90, and then we go a little bit more, and that is the angle theta, which is negative 100 and, so we went in that direction, negative 135 degrees. So we're going to do the same thing. The reference angle is going to be formed with the x-axis and the terminal side of our angle. And so it's going to be this one right here. That is theta prime. Now, how could we find theta prime? So remember, theta prime reference angle must be positive, and it also must be acute. And so one thing we could do is to consider 180 degrees, because that will be half a circle. So to find theta prime, I will use 180 degrees and subtract the original theta, or add the original theta because it was already negative. So this will give me positive 45 degrees. Now, if you're not sure, should I take 180 and subtract 135, or should I take 360 and then subtract 135? You know, that could be a common question. So if you were to try that, I will show you that you will get 225 degrees. And so that cannot be a reference angle because it's not acute. It must be acute, less than 90, and it must be also positive. So that would be 45 degrees. Now we're going to see on the next slides how helpful those reference angles will be. To see how a reference angle is used to evaluate a trigonometric function, consider the point xy, the one that we have here, and on the terminal side of theta. So again, we always in standard position, this is theta, and the terminal side of theta, it's here. Oh, and I put a prime there. It should just be theta without the prime. Okay, that is our angle. Here's the terminal side. That is the point. So based on what we have been learning, we draw that perpendicular line. And again, I like that the right angle is here, so that tells me for sure it is perpendicular. And the reference angle will be formed with the terminal side and the positive x-axis. And you can see right there, that is theta prime. Now let's talk about the signs of these points. Before that, let's look at the what we have here. So if we had a real triangle like we did at the beginning, we will say, and let's say this is the angle in question. Let's just call it theta prime. And so the opposite side to that will be here, and the adjacent side will be here, and this will be the hypotenuse. So when you have a triangle, you will consider the positive values because they're about length, and that's why we're using the absolute value of each of these. However, if we are working with any of those angles, if they are more than 90 or between 90 and 80, those will be in quadrant 2. For angles in quadrant, I'm going to extend the lines here. For angles in quadrant 3, those are the angles that are bigger than 180 or bigger than pi, but are smaller than 270 or 3 pi over 2 radians. And then the ones that are in quadrant 4, of course, will be the ones that are greater than 270, but they're smaller than 2 pi. So depending on where the terminal side of the angle in question is placed at, that's what will determine the sign of your trigonometric functions. So for example, if we have an angle in standard position that starts here and ends in quadrant 3, then we have to consider that the x and y coordinates will be negative, both of them. And so that will make sine negative, cosine negative, and tangent positive. If your reference angle was in, actually we kind of skipped this one, in quadrant 2, not your reference angle but your terminal side, then your x and y, there will be negative for x and positive for y. So that will tell you that sine will be negative, sine will be positive, cosine will be negative, and tangent will be negative. Now lastly, if we have an angle that goes from positive x and the terminal side is in quadrant 4, then for that angle, the coordinates will be positive for x and negative for y. So that means that sine will be negative, cosine will be positive, and tangent will be negative. This next slide, it just reaffirms what we discussed on the previous one. And so the steps to evaluate trigonometric functions of any angle, and number one, it will be to determine the function value of the associated reference angle. I would say probably find the reference angle first, and then you determine the function values for that reference angle. So what we mean by that is you will find sine of theta prime, cosine of theta prime of the reference angle. And we will do an example in a minute. And the tangent of theta prime. That is what they mean by the function values. So, and let's say step 0 is find reference angle first. So after that, let's move on to step 2, and depending on the quadrant in which theta lies, affix the appropriate sign to the function value. And so we already discussed that. We will have here positive, positive. Here we will have negative, positive. And here we will have negative, negative. And lastly, here we have positive, negative. So if we write them in order of sine, cosine, I'm actually gonna zoom in here so I can have more space. Okay, so if we have that sine, cosine, and tangent, we know that they will be positive, negative, and negative. In quadrant 1, sine of theta is positive, cosine of theta is also positive, and tangent of theta is also positive. If we move to quadrant 3, sine of theta is, the y's are negative in quadrant 3 and 4, so this will be negative. The x is also negative, so the cosine will be negative. And the tangent, since it's the ratio or the quotient between these two, if you divide a negative by a negative, you get positive. Now, finally, in quadrant 4, what we're going to do is we're going to have a positive, a negative sign because the y's are negative in quadrant 4. For cosine, it will be positive because the x values are positive in quadrant 4. And for tangent, if we divide two numbers of opposite sign, we will get negative. You can really extend the scope of exact trigonometric values without the use of your calculator. And knowing the function values of 30 degrees means that you actually know a lot, and you know everything that has the same reference angle of 30 degrees. And so when I say that, I mean, let's say that this is 30 degrees. So the sine of 30 degrees, remember that's my favorite, is 1/2. The cosine of 30 degrees is the square root of 3/2. And the tangent, if you don't remember what it is, you could always do the ratios of the sine and the cosine. So if we do that, we multiply the outer quantities, so that would be 2 times 1. Inner quantities, that will be 2 times the square root of 3. Those two cancel out, and of course we get 1 over the square root of 3, but you must rationalize, so multiply by the square root of 3 times the square root of 3, and that will equal to the square root of 3/3. Okay, so those will be the 3 trigonometric ratios or function values for 30 degrees. Now, what does it mean that you know more than that? So, another angle with the same reference angle is going to be the one that starts here, ends here, and it will be 30 degrees before it gets to pi, or to 180. So imagine 180 minus 30, that will be 150. So I'm going to use a different letter. If alpha was, that's another Greek letter, so 150. It will have the same trigonometric values as 30 degrees. However, the sign, actually I'm going to write it here, sign of 150 will still be positive, so it will be 1/2, positive 1/2. But when we write the cosine of 150, that one will be negative, because for that angle, the terminal side is placed on the second quadrant, and the x values are negative in the second quadrant. So then instead of negative of the square root of 3 over 2, it will be the negative square root of 3 over 2. That's how it will work. Let's get one more angle that will have the same. And that could be an angle, again, standard position. We start here and we go past 180 and we go a little bit past 180. And just to let you know, the reference angle will also be, and actually instead of calling this one theta prime, I should call it alpha prime, because I'm talking about the reference angle for that one. So let's call this angle, all right, I'll use theta prime. And so if you notice, that one will have the same reference angle because it went 30 degrees past the x-axis. And so that will be 180 plus 30. So that will be 210. So that means that the original angle was 210 degrees, but the reference angle is also 30. However, if we want to find the sine of 210, it will be 1/2 but negative. And the cosine of 210, it will be also negative, and it will be negative the square root of 3 over 2. And if we wanted the tangent of 210, it will be positive because we will be dividing two negative numbers, and that will be this number, the square root of 3 divided by 3. Oops, it's almost there at the page number. Okay, and just one more. I'm not going to do the whole thing, but if we had an angle that started here and it went like that, and then it stopped 30 degrees before getting to the x-axis. So in that case, that angle will be 360 minus 30, so it will be 330 degrees. That will be like the original angle. Let me call it beta. So the reference angle, it's beta prime, it still happens to be 30 degrees. And I say I wasn't going to do it, but if I ask you just quickly, what is the sine of 330 degrees? Because the y's are negative in quadrant 4, sine will be negative 1/2. But the cosine of 330, it will actually be positive because the x's are positive in quadrant 4. So it will be the positive square root of 3 over 2. For convenience, the table below shows the exact values of the sine, cosine, and tangent functions of special angles, and also for the quadrant angles. Those are 0, 90, 180, and 270. And of course, if we were to put 360, because it is after completing one revolution, the values will be the same as the ones for 0 degrees. Okay, so we have the special angles that we've been discussing a lot: 30 degrees, 45 degrees, and and 60 degrees. So make sure you remember that 30 degrees is pi over 6, 45 degrees is pi over 4, and 60 degrees is pi over 3. Remember, the bigger the denominator, the smaller the fraction. So it makes sense that pi over 6 is smaller than pi over 3. Okay, and of course, I don't think you have issues with 90 is pi over 2, 180 is pi, 270 is 3 pi over 2. And remember that the quadrant angles, you know those because you could plot those points on the unit circle, and with that you could write down the coordinates such as 1 0 0 1 -1 0, and here we have 0 -1. And remember that if knowing x and y, you already know what the cosine is and the sine of those particular angles. So that's pretty easy. Also, we went over how some things are undefined if x or y is equal to 0. So that's why we see here tangent being undefined at 90, because at 90 degrees, that will be here. The x is 0, and tangent is sine over cosine. That is the quotient identity. And so if the cosine is 0, of course, it makes sense that our tangent will also be undefined. Similarly, for 270 degrees, the cosine is 0, is this point here, the x value is 0, and so it makes sense that our tangent is undefined. And another way to remember, there are a lot of tricks to remember them, but if you think about it, you start here with something like the square root of 0 over 2 equals 0. This will be the square root of 1 over 2, and that will just be 1/2. The next is the square root of 2. We leave it like that because it is irrational. Then we have the square root of 3. And all of those have the same denominator of 2. And here finally we have the square root of 4 over 2. And that actually happens to be 2 over 2, which is 1. And if we look at the ones for cosine, they go like in reverse. And it's no coincidence. Remember, we discussed cofunction values, such as the sine of 30, where is that? Right here. 1/2 is the same as the cosine of 60, because 30 and 60 are complementary angles. And of course, for 45, since 45, the complement of 45 is also 45, it makes sense that both the sine and the cosine are the same. So let's move on to our final examples. So we have here to evaluate each trigonometric function. And so instead of doing all 6 of them, we're just going to find cosine, but it says each because we have 3. It's 3 different angles. Okay. So the first angle, which is theta, is 4 pi over 3. And so recall that right here, 180 degrees is the same as pi. If I was to write pi in terms of thirds, it will be 3 pi over 3, right? Because that is equal to pi. So if our angle is 4 pi over 3, we could actually split that into 3 pi over 3, and then we have an extra pi over 3. Or in other words, what I'm trying to get is that we will go pi radians, and then that will be this one, pi radians, and then a little extra piece, and that extra piece happens to be pi over 3, which is this one. And that pi over 3 is what happens to be our reference angle. Now, pi over 3 is the same as 60 degrees. Don't be confused. And so remember how I always say my favorite is 30 degrees, which is also pi over 6. So I love that one because it's just so easy. It's 1/2. And remember, since 30 and 60 are complementary, it means that the sine of 30 is the same as the cosine of 60. In other words, the sine of 30 is the same as the cosine of pi over 3. Pi over 3. That's 60 degrees. And so that's actually what we needed. And that is also going to be a 1/2. However, is this going to be positive or negative? Now, since the terminal side is in quadrant 2, and in quadrant 2, both x and y are negative, so that means that cosine, which is based on the x value, will be negative. So the answer is negative 1/2. Next example, we have a negative angle, which is negative 210. So we are going from the positive x-axis in the clockwise direction. And so it will be right here. So we know the reference angle is 30, but because we have the image here. But if we didn't know that, we will say 210. How do I want to do this? Okay, so for theta prime, I will say 210 minus 180, and that will give me 30. Remember that we always want to have a positive angle for our reference angle. So this is 30 degrees. And that is why I didn't say negative 210 plus 180, because if I had done that, my answer would have been negative 30 degrees. And that's not okay for the purpose of a reference angle. Okay, so that's why I made the 210 positive. So let's see the tangent for that one. Since the sine of 30 degrees, remember, it's my favorite, it always comes back as 1/2, and the cosine of 30 degrees is the square root of 3 over 2, then the tangent of 30 degrees is going to equal to 1/2 divided by the square root of 3 over 2. And so that will give me 1 over the square root of 3. That, after rationalizing, it will give me the square root of 3 over 3. So that is the number that we need. However, we need to figure out if it will be positive or negative for this particular question. Since the angle negative 210 has a terminal side that is in quadrant 2, we know that the x and y values, the x's are negative and the y values are positive. So tangent, based on the fact that it's also defined as y over x, if we divide a positive and a negative number, we're going to get a negative number. So that will be negative square root of 3 divided by 3. So let's move on to our next example, and we're going to evaluate the cosecant of 11 pi over 4. Now, to draw 11 pi over 4, we could do the following. If you have 11 fourths, and you convert this into a mixed fraction, it will be 11 divided by 4. It goes in 2 times. And then we have a remainder of 3. So to draw an angle like that, I'm going to start from here, start fresh. So we start at the positive x-axis. We go in the counterclockwise direction. This 2, the integer, it means that we're going to do 2, well, let me add the pi here. So 11 pi over 4 will be 2 pi plus 3 pi over 4. That's what it will be. So I'm going to go 2 pi radians, so that means a full turn. And then I'm going to go 3 pi over 4 more. So right here, that's 2 pi over 4, half a circle, and then another pi over 4. So we end up there. So that is my terminal side. And we already know that the reference angle will come from here. And how could we find that? So if we didn't know, we could say 11 pi over 4. And then, let's see, what would I do? I will subtract 2 pi, which in fourths, it will be equivalent to 8 pi over 4. So after doing that, I will get 3 pi over 4. Now, can we use 3 pi over 4 as our reference angle? No, because a reference angle is acute, meaning less than pi over 2 or less than 90 degrees. So then to 3 pi over 4, we go ahead and we subtract pi. Do we subtract pi? Well, that will give us a negative angle. So let's do it the other way. We will take pi and then we subtract 3 pi over 4. So we know that pi in terms of fourths, it will be 4 pi over 4. And if we subtract 3 pi over 4, we will get pi over 4. So that is another way we could figure out that the reference angle will be pi over 4. Now, we are going to need the sine of pi over 4. It's a very simple one because it's the square root of 2 over 2. But before rationalizing that one, the answer is 1 over the square root of 2. And so if I want to find the cosecant of pi over 4, I will use the reciprocal of sine, meaning that I will put my square root of 2 on top and my 1 on the bottom. So the answer will just be simply the square root of 2. However, for this sine, for this cosecant, cosecant and sine are both related to the variable y, and so the variable y in quadrant 2 is positive, so it will be the same thing. So the cosecant of 11 pi over 4 will also be positive square root of 2. And that was our last problem.